Well, good afternoon, everybody. This is Dave Jones with Storm Center Communications and GeoCollaborate. It is December 6th, 2024. It's Friday. We made it through the week, and this is a weather impacts update for the All Hazards Consortium, the sensitive information sharing environment, where we share information across platforms from private sector liaisons that work in state emergency operations centers, also to the private sector partners that they serve. Those are folks in like the food, fuel, medical supply, logistics, communications, utility industries that really work to keep the economy moving and the lights on. Well, this time yesterday, we were talking about this 7.0 magnitude earthquake that hit off the coast of California. And you can see on GeoCollaborate, this was the center point of the earthquake. And all of this indicates this is where that earthquake was felt. So quite a bit of north central California, even in Sacramento, the earthquake was felt pretty strongly. Now, officials from California are out and inspecting bridges and roads and airports and buildings and schools and things like that to make sure that there's no residual damage from this earthquake, and doing inspections for potential landslides. There have been a lot of wildfires in Northern California. It really changes the hydrophobicity of the soil. That means that when rain hits, it rolls right off. So if you have an earthquake, it could shake that loose. Then when it rains, you get a lot more mud flows, mudslides, debris flows, and things like that. So we want to make sure that it's very safe here. And the folks in the state of California are out there working very, very hard to inspect any damage that happened. Now, I want to show you an interesting animation that was put together by NSF and their partners just yesterday during the earthquake, because we have seismometers around the country that monitor this. I'm going to show you the ground motion visualizations. So this shows you how waves travel away from an earthquake by animating the motion of the ground as detected on seismometers. Each dot shown in this animation coming up shows when the ground moves up, the dot turns red. And when the ground moves down, it turns blue. So waves generated by earthquakes travel around and through the earth, but they get smaller or attenuate, scientific term there, as they move away from the earthquake. So this attenuation dampens as it moves further away, just like ripples in a pond. When you throw a stone in a pond, you see those ripples come out. So picture that. So once the earthquake waves are far enough away from the location where the earthquake occurred, they can no longer be felt by people, but they can still be detected by sensitive seismic instruments. So I want you to take a look at this. This is before the earthquake happened. And when the earthquake happened, bam, you can see the seismic sensors detecting the waves now going through the land, the US, Canada, up into Alaska. Look at that. These are the ripples from that earthquake happening. And it was not a deep earthquake either. So these are fairly shallow. It doesn't mean that on the United States, on the East Coast, that people felt it, or out down in the Caribbean. Look at that. These are sensors that are still moving because the ground is moving like this across the United States and around the entire world. And it can be detected. It is really quite fascinating. So what I want to do here is I had the opportunity to catch up with Storm Center's chief scientist, Dr. Ellen Prager, earlier today to ask her about the earthquake and the resulting tsunami warning that was issued. Well, we're fortunate enough to have Dr. Ellen Prager, Storm Center's chief scientist, available today to talk a little bit about the earthquake that happened yesterday. And Ellen, thanks so much for joining us. I know that the earthquake was initially like a 6 point something, maybe a 6.5 or 6, and then it was 7.3, but then it kind of settled on a 7.0. Can you tell us a little bit about how that process works?
That's right. First, if people were watching, they may have seen an alert for a 6.6 magnitude earthquake off of the coast of California. It was at about 8 miles depth. But what happens is, over time, the U.S. Geological Survey gets more information from their seismic stations, and then they update to what the magnitude really is. And so what you saw is it went from a 6.6, and then a little bit later, they updated it to a 7.0 magnitude earthquake, which, especially at that shallow depth, is a significant quake.
Yeah, and I was just on that one graphic that we were showing before. Some of the information over the land was the USGS's probability of landslides happening. But so, I'm really curious when an earthquake happens so close to the coast, how in the world, or how fast does a tsunami travel, first of all, out in the open sea? How fast does it approach the coastline? And what should people do if they feel an earthquake and they're along the coast there?
Well, a little bit more about this earthquake. So it is sort of relative to the question that you're asking. It occurred in what we call a triple junction, where three different plates are coming together or touching, and it's a very active seismic zone. So the good thing is that people in the area are used to earthquakes, and California is one of the best places for creating an alert system and telling people what to do. So it was in this triple junction area, and it turns out that it was a strike slip fault, meaning that you had two plates or within a fracture zone, you had them moving one past the other, sort of sliding. These are called strike slip faults. They typically do not produce the huge tsunamis that we see that come with subduction zones, where you have one plate going up and the other plate potentially going down. But strike slip faults can, in the past, we've seen them actually produce tsunamis through submarine landslides. So you have to be careful. Even though they found out it was on a strike slip, they still had to produce the alert because it could create a tsunami. And just like you were saying, it was very close to shore. Now, tsunamis in the open ocean, they actually travel about the speed of a jet plane, about 500 miles per hour. And what happens is, as that tsunami wave approaches shore and it gets into shallower water, it does what we call feels bottom. It starts to feel the bottom, and the friction from the bottom starts to slow the wave down. Unfortunately, it also causes it to steepen, which is a big problem, but it can slow down to something like 30 to 40 miles an hour when it hits shore, which is too fast to run away from. So here's the bottom line. If you're in the coastal zone and you feel strong shaking, you're not going to know if it's a strike slip fault or it's a subduction zone fault. And so you have to evacuate and go to higher ground. And that's what happened in California. They had to immediately send out alerts and start telling people to evacuate and go to higher ground. They would have, if there had been a tsunami, they might have had 8 to 10 minutes in the direct path of it. So you just don't have time to wait around and think, should we issue an alert? They had to do it. Now, could we get better at this? Boy, being that close to shore, it's really tough. And there's no system right now that can actually tell us immediately whether a tsunami has been created or not. So they had to issue that alert.
So that's really interesting information, Ellen. Thanks for that. And also, having an earthquake that close to shore, is there a possibility that they may see aftershocks as strong or stronger than this?
Well, having an earthquake anywhere, you're almost always going to get aftershocks. And we're pretty good at predicting now how many aftershocks over what time period. Typically, you get aftershocks that are less intense than the main shock, and this has been called the main shock. So over time, there are going to probably be hundreds of aftershocks, and I've already seen records of magnitude 3, 4s, 2s. There are going to be a lot of aftershocks, but they shouldn't be as strong as the main shock.
And I want to let everybody know that's watching right now that the graphic that you see on the screen, those white dots, are not aftershocks. It's actually historical earthquakes, and as Ellen was mentioning, along the fault zone there. So it's the earthquake happened at an expected location. That's where it happens, and it happened yesterday. So this is great, Ellen. Thanks so much for joining us. We're going to talk about answering another question that a viewer had yesterday, and that is, could the atmospheric rivers have anything to do with the earthquake? And we're going to do that right after this. Okay, well, now we're back. We really appreciate that expertise from Dr. Prager. We have been talking about an atmospheric river coming into the Pacific Northwest, And now we can show you it's really coming together now. And it could be a little bit stronger up in BC, British Columbia, parts of Canada, and maybe Vancouver. And I'm going to show you that. So here is the GOES satellite image from the west. GOES West, GOES 18 it's called. And you can see I have, don't fear, this orange color and red color. That is dry air. So dry air is usually our friend, unless we're in a drought, of course. But this is that fire hose of moisture that's hitting right now into British Columbia. And it's going to slowly sag to the south and impact Washington State and also the coast of Oregon. And I want to show you that on the models as we talk about this for the atmospheric river forecast. So let's take a look at that. Remember, we were talking about this yesterday, and I'm going to bring this up here just a little bit because I want to show you where these dots on the west coast are and what I'm talking about. So we're going to talk about this particular atmospheric river coming into the west coast, and you can see the dots. These dots represent the level of atmospheric river, or the category that the atmospheric river is expected to be in this area. And so blue is weak and yellow is moderate. And so you can see the blue is weak, yellow is moderate, and the green is strong. So this could be a strong, sorry. So looking at the category here, atmospheric river, AR1, 2, and 3, that's what we're talking about because you can see some yellow in here. AR1 is weak, AR2, the green, is moderate, and AR3 is strong. So there does look like to be some strong impacts from this atmospheric river around these dots. Now, what I'm going to do is I'm going to take and look in British Columbia. You can see these yellows here. They've been getting hit by this atmospheric river over the last several days. And this is the next one that might be coming here in the next few days. But it's just starting to end now. Starting to end up here because, remember, I showed you in the satellite loop. In this satellite loop full, whoops, I want to go back here. When I showed you in the satellite imagery, that is moving. It's now impacting up here now, which is yellow, but it's going to be sagging to the south here. Okay, so let's go back to the model forecast and what that looks like. So as we move to the south, I'm going to move down south through British Columbia here towards Vancouver, and I'll stop here. You can see this is the atmospheric river that is impacting them now because this center line is right now, and it's going to last through until late tonight or early tomorrow morning. So it should be ending late tonight and early tomorrow morning. If you're experiencing localized flooding in western British Columbia along the coastline there, that will ease up during the evening tonight. And I want to move down here. Here's Vancouver Island. Now, Vancouver, you're going to start to experience it right about now, and it's going to last through today into early tomorrow morning. So that is those clouds that are sagging to the south, and you'll be getting that rain impacts. Now, the yellow, since that means that it could be a strong atmospheric river, more or less strong or moderate, there could be localized flooding in your area. So be prepared for that. And again, that's going to onset here right about now. And let's move south into Washington State. Even some moderate atmospheric river could be experienced here over the next 12 hours, 12 to 18 hours. You can see this is the yellow, and this is today. This is tomorrow, Saturday, and this is Sunday. And so it looks like today into tomorrow morning is when you'll be experiencing some moderate heavy rain at times with this atmospheric river moving in. Okay, let's move to the south just a little bit, down towards Astoria, where the mouth of the Columbia River is. This looks like a green AR2, so that means a moderate atmospheric river could be coming in to the Columbia River Gorge in here around Astoria. and also parts of Washington and Oregon. And it doesn't look like it's going to last very long. It'll last about 24 hours, starting a little bit later today, and then ending tomorrow around noontime or so. And then down towards Oregon, look at this. It just becomes a weak atmospheric river, and the further south that I go, its duration is going to be less. And that is because when we show this forecast coming in, and let me see if I can go over here to this and see if this works out. Yeah, so let me move this a little bit further up here like this, and you can see what it looks like. This is what we call integrated water vapor. It's almost like we see in the satellite picture that I showed you earlier with that stream of moisture. You can see it hitting up into British Columbia now. Here is here's Washington, here's Oregon, and as we take this further ahead, you'll see how this starts to move to the south. And that's why you're going to start to get this fire hose in Washington State and parts of Oregon later on today and into tomorrow morning. But look, it doesn't really last that long. It goes down towards Northern California, but it really kind of peters out here and then just stops. The atmospheric river kind of stops. It doesn't make connection anymore with the western United States, with California. That's still an atmospheric river, but it's not having any impact on the United States. So as we go out into the future, it looks like that's going to be it for a while. But look at all this moisture down here to the south. It is pretty incredible. And again, this is what it looks like. This is that moisture. This is the satellite imagery that we're looking at, and you can see that streaming on into British Columbia. Lots of dry air down here in Southern California. Also lots of dry air in northern Mexico, dry air in parts of Arizona and New Mexico as well. And looking over on the horizon, that's looking towards the East Coast, where it is pretty darn cold right now. Here's what it looks like from the standpoint of the Goes East satellite. And you can see that Terminator line. Here comes the sunset. That's coming down through Maine again. Happens every day. And it changes as the seasons go, with the North Pole getting more light in the summer, less light to no light during the winter time. But here's that strong cold front that passed through yesterday. It's already well off the coast, a strong low pressure system there up north of the Canadian Maritimes there. But look at all this cold air. I'll zoom in here a little bit so you can see the cold air streaming over the warm water, creating all these clouds. There may even be snow showers out here. We talk about lake effect snow a lot. Well, this is ocean effect, and it is a beauty. All the way down here off the coast of Jacksonville, Florida, cold air forming these clouds over the ocean. So it is very, very windy out there. And the lake effect snows continue too. Let me take you a little bit closer here for what it looks like. This is the 1 minute imagery. And look at this over Maryland and Washington, D.C. Lots of wave clouds happening here. And if I go back up towards the Great Lakes, look at that. This is Lake Erie here and Lake Ontario. So they're still getting lake effect snow. In some areas, getting heavy lake effect snow. They've already had a winter, and it's only December 6th. So that's what it looks like from a satellite perspective. I want to show you what it looks like from temperatures around the country, because we do have some colder temperatures. So let's go and take a look at that. I even included some of the buoys and also down towards Central and South America. Look, you want to get some warm temperatures? Look at this, down through western Mexico, 86 degrees, Central America, temperatures in the 80s. Very much used to that. That's how it goes usually during the winter time, because it's in the tropics, of course. Puerto Rico, temperatures in the 70s there. Even in southern Florida, temperatures in the 70s. We'll get a little bit closer here, resolve these temperatures a little bit more. Even down in Miami, temperatures right now in the 70s, low 70s, 73 down in Key West. And this is where the cold air is. Look at this. Temperatures in the upper 30s right now in the southern Appalachians and northern Georgia. 20s all up and down the Appalachian spine with the higher elevations there. And on up into the mid-Atlantic area. Look at this. Temperatures at or below freezing. A little bit above right now in southern Maryland and central Maryland. Temperatures in the 30s. But even out to the west, look at this. This is where the cold air is, and that's where it's going to be, for the next 24 to 36 hours. Even in Nebraska, South Dakota, North Dakota, you're going to start warming up. Look at this. In western South Dakota here, 63 degrees right now. Beautiful day after being pummeled by that cold front with those very cold temperatures below zero in some cases. But look at this, temperatures in the 50s and 60s throughout Kansas. When you get over towards the mountains and the Pacific Northwest, temperatures, of course, with elevation go down in the 20s. In the Pacific Northwest, temps in the 40s, and then down towards Nevada and Arizona and Southern California. Very comfortable down here with temperatures, as they should be in Southern California in the 70s. So what I'd like to do is just show you a little bit of update on what kind of advisories are around the country right now. Remember, we had so many advisories last time from the National Weather Service, and I want to show you GeoCollaborate. And let me back out here just a little bit. Here's GeoCollaborate, and you can see a lot of the lake effect warnings have been canceled up in New York. They're still in effect. There's still down here in Georgia some advisories for special weather statement here, and also some gusty winds and cold temperatures there. And also down in northern Florida, a freeze warning in effect all the way down here. Look at this. This is a freeze warning. So bundle up and protect the sensitives out there because temperatures are going to go down tonight into the 30s. In many areas highlighted in that purple area. But let's go up here into the Great Lakes area. Still windy along the East Coast. There are small craft advisories that are going to continue for the next 24 hours at least. But then over here on the eastern edge of Lake Ontario, we have winter storm warnings going on because of heavy lake effect snow. And over here are winter weather advisories. So not as much snow expected, but still heavy snow. Here is that light blue color that we don't like anymore in Erie County and southwestern New York. This is lake effect snow warning. That's going to be in effect. Let's see, it looks like it expires on December 7th. So that is tomorrow. Tomorrow morning, it looks like. If that's 5 o'clock, I think that's local time, 5 o'clock in the morning. Tomorrow, that's when the wind should ease up. If it's 5Z, it's midnight tonight is when it expires. I know you've had enough snow already. Even around Lake Michigan, it's still windy there, and there are gale watches in effect. That means winds could approach 25 to 45 mile per hour winds. When they get to 50 mile per hour winds, it is a storm warning that's in effect. And out to the west here in parts of Montana and Wyoming, we have high wind watches. Remember that that atmospheric river is coming ashore, so it's going to be creating at higher elevations some high winds here. And in western Montana, winter weather advisories in effect for some light snow accumulations. And look at this, out in southern Oregon, air stagnation advisories. So in the valleys, air quality. Let me take you over here. Sorry about that. These are air stagnation advisories for light winds in the valleys where air pollution could really dominate, and that is not healthy at all. So what I'd like to do is show you the model forecast. We'll get through this and get through it pretty quickly here because there doesn't look to be any major weather events. We have that atmospheric river coming in that could be causing some flooding in the Pacific Northwest, particularly along the coastline there. But you can see what it looks like. This is a wide view. Here's the United States. Here's Canada, Alaska. Right up here, here's the Aleutian Islands. Here's Mexico down here, Central America. Here's Cuba and Florida. So I'm going to put this into motion to show you what it looks like with the initialization of this model. And we're going to put this into motion so you can just watch the weather systems move around. By the end of the weekend and Monday, it looks like this rain area is going to be pretty extensive from the upper Great Lakes into the mid-Atlantic. So it doesn't look like a great Monday in the mid-Atlantic area. And frontal system stretching down into Texas and Louisiana. There'll be some scattered showers there during the day Monday as well. In the Pacific Northwest, you're drying out, but there's more cold air coming down. There's an Arctic high pressure system here that's going to be pushing down here, and you'll see that in motion as I put it into motion here. Now, this is cold air coming in behind this front, and this is on Wednesday evening, Thursday morning. Take it back a notch or so here so you can see that frontal system that's coming through. This is all rain, it looks like, for the most part, all rain on up into Maine and mid-Atlantic into Florida. This is on Wednesday, December 11th. However, sharp cold air coming in behind this could turn some of this to snow as this low moves on. And so I'll put this into motion. You can see the cold air dominates and the rain and snow mix moves out of the way. High pressure will take over during the day Friday on December 13th. So good weather in the mid-Atlantic and just a few snow showers in the upper Midwest. But primarily, look at this. 2 high pressure systems dominating for much of the country during the latter part of next week. And then we have another system moving into the Pacific Northwest. This could be another atmospheric river. We'll be keeping you updated on that for sure. Doesn't look like it has a big connection to the tropics here, but just some rain. And then, this rain is good for the upper levels, the higher elevations where the reservoirs are, because that's where the West gets most of their water for about a year or so it takes to drain those reservoirs. And then on into Tuesday, we're talking about December 17th, hour 252, Fantasyland. We'll stop right about there. It looks like another system might be coming into the Pacific Northwest. That is a week from this coming Tuesday. So that is far away. Now, let me switch over to the temperatures because I want to show you just where the cold air and where the warm air is. And we have the cold air on the East Coast right now. You can see it by that blue, all this blue area. That's cold, and up into the upper higher elevations of the Rocky Mountain West. Cold temperatures there too. Great for the ski resorts. You'll see as I put this into motion here, the cold air generally pulls away. And by Sunday, look at this. Temperatures Sunday in the 60s in parts of Virginia, maybe touching 60 degrees in the mid-Atlantic area, and certainly nice and warm in Florida. So you won't have to wear those parkas anymore in Florida that you may have taken out for 1 or 2 days. But I'll put this into motion. You can see how the warmth and cold kind of oscillates. But here's that next push of cold air, and that happens next week. That is next Thursday. Remember I told you that cold front comes through and brings that Arctic air back in. It won't last for a whole long time, but it is going to come in and sweep through, and then temperatures will moderate a little bit more. So no real Arctic air in the picture for the middle and lower U.S., but you can see up here in south central Canada, yes, that is where a lot of the cold air likes to store itself, and then low pressures and high pressures grab it and try to take it down on into the United States to make us shiver for a while. And when that cold air mixes with moisture, that's when we get all of that precipitation. So I'll leave you with the western satellite picture here. That atmospheric river is beginning to impact British Columbia. It will sag down and get Vancouver and Canada, and then Seattle, and then down towards Portland. And remember, there could be some localized flooding, but it won't last really long. Over the next 24 to 36 hours is what you'll have to deal with. So that's it. Thanks so much for watching this update. I'm Dave Jones with Storm Center Communications and GeoCollaborate. We're also monitoring for earthquakes, so when they happen, we'll be back for more information. Hope you enjoyed that explanation from Dr. Prager. We'll have her back more. She is not only a marine scientist, she also has geology in her background, knows a lot about earthquakes and volcanoes, and she's also an aquanaut. So we'll probably talk a little bit about living underwater. That could be very interesting. So have yourself a good weekend. Thanks so much for watching. Maybe back tomorrow, but maybe not until Monday. We're going to watch the weather, see how things go. Until I see you next time, thanks so much. And please take care of yourself and also take care of your neighbors. They sure do appreciate it. Take care.